the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
All right. So it's a big pleasure to introduce today's speaker, Rachel Spellman. At the beginning of the semester, I promised that I'll bring several of our alums to speak in the spring session so that our current students get inspired by them. Amanda was here already. Today it's Rachel's turn. And then like in a few more weeks, we are going to have Mradula and Isabella joining us as well.
Mm-hmm.
So Rachel works as the lead sustainability analyst at APIS Innovation, where she focuses on using data-driven insights to optimize methane capture at landfills and reduce emissions. So with experience in both corporate and startup environments, she has worked on several projects already, from life cycle assessments to carbon footprint measurements, helping organizations understand and improve their environmental impact. So Rachel got her bachelor's in business and technology from Stevens, and then joined the dual degree MS MBA program in sustainability. So she graduated in 2023, and she's already the lead analyst. So somebody, like, again, I think we have to mute someone. Okay. All right. So great. Like, again, you are already the lead analyst there. Very, very, impressive. Today, Rachel will talk about how to reduce methane emissions by bridging data and communications. So welcome back, Rachel.
Thank you. Yeah, excited to be back. Yes, Dibs mentioned, today I'm going to be talking about bridging data and communications to drive methane emission reductions, specifically at landfills. Can get into that. Yeah, so I'm just going to do super quick background on, methane emissions at landfills, then kind of dive into what my company does, kind of the role that data plays in my job there, just kind of briefly going over aligning sustainability and business strategy, and then show you guys a couple of examples. Awesome. Yeah, so I won't go into this too much, but yeah, like Deb said, I did my undergrad and my graduate at Stevens. Actually, the company I work for now was founded at Stevens, so big Stevens person over here. Yeah, but just as like a quick background of some of the other like work experiences I've had in case anyone ever wants to reach out and ask any questions. Yeah, like I said, kind of a range of startup and corporate work. So kind of started off doing marketing for a company called Regrow, which uses drones and satellites and aircraft to map emissions in the agricultural space. Switched over to Mondelez, which is like the Oreo Nabisco company, and did supply chain and then marketing there. Then worked for a beauty startup called Pros. They did like made to order hair care and skincare. And finally, I work at APIS, which I'll dive into what we do later. Also a startup. So yeah, I've had kind of a mix there. So, all right, moving on. First, just kind of before we get into what our company does, it's kind of helpful to have maybe a little bit of a background of, methane specifically at landfills. And then I'll dive into, kind of looking in that space. Obviously, I know all of you are in the sustainability program, so I won't dive into, specifically what are methane emissions. We'll say, we know it's colorless, odorless, highly flammable, produced naturally, but obviously through human activities, that's amplified. Specifically in my case, really looking at the decomposition of organic matter in landfills is what's driving those methane emissions. Why should we care? Obviously, there's a host of environmental and health, as well as other like economic and social impacts, things like global warming, ecosystem disruption, links to respiratory diseases. As we all know, a host of problems kind of from this space. And I think the most kind of alarming stat on methane emissions is it's 25 times more potent than carbon dioxide emissions over a 100-year period. So, kind of looking at and tackling these emissions, specifically in the space that I'm in, is kind of the main focus. All right, so this is pulled from our world in data, but just looking at methane emissions by country, obviously we can see North America as well as certain countries in Asia tend to have just, higher methane emissions, maybe as compared to, Europe and Africa. For us, sorry, I'm going the wrong way here. For us specifically, we operate in the US and Canada. So kind of narrowing in on those areas, looking at what are the largest sources of methane emissions. 1, we've got oil and gas, 2, agriculture, and then 3 is municipal solid waste. So there's already been a lot of work and kind of regulations passed within the oil and gas. I know if anyone's kind of keeping up with that space, there's been some changes in the last few days, but there's been a lot of work in those spaces to try and like combat methane emissions. So now there's kind of this bigger focus on what can we be doing within the waste industry to kind of combat some of those methane emissions. Awesome. Okay. Super quick overview of kind of a landfill just before we dive into things. Again, my background is in business. I will try my best on any super technical questions, but just to kind of give a quick overview. So moving from the left-hand side of the screen to the right, we've got the working face or active area of a landfill. That's maybe like the traditional thing that we all think of, the open area where garbage gets dumped, that's not covered. Once an area is filled, we have what's called final capping systems. So a cover system is put in place that helps to kind of cap those emissions from being released into the atmosphere and minimizes stormwater infiltration. So what does that cover look like? Topsoil, drainage blankets, geomembrane, things like that. That's kind of that middle section. And then the kind of third stage over there, landfill gas capture is kind of the space that my company sits in. So after that final capping has taken place, if a landfill is over a certain size or has certain amounts of waste in place or has modeled emissions that are over a certain amount, we've got regulations in the US and in Canada that essentially enforce landfills to install what are called gas collection systems. What does that mean? Essentially, a system of pipes and wells are put in place in order to capture that gas. As you can kind of see, there's like a little above ground feature on, this kind of side of the screen. I'm not sure if you guys can see my mouse, but essentially what that is from the surface of the landfill, there's a system of like the pipes kind of hit the top, and then you're able to kind of control the flow and really optimize landfill gas capture. And then in an ideal situation, we'd take the gas that's being captured and use it for beneficial use. So landfill gas to energy projects, renewable natural gas, like RNG is a really big kind of player in this space now. Obviously, that doesn't always happen. Sometimes it gets flared, but flaring, even just the landfill gas that's kind of coming out of the landfill is still better than it just being released into the atmosphere. All right, kind of where my company fits in on that like massive picture with a lot to cover. Kind of our main product, which I'm going to dive into a little bit more later, is an automated wellhead. So basically it's a device that was created that sits on top of the well and automates that collection process. Okay, so kind of diving into APIS. As I mentioned, our company was actually born at Stevens. So our CEO actually grew up, his family had a landfill, so he was really immersed in this industry, became super frustrated with the inefficiencies of manual tuning, which needs to get done on those gas collection and control systems. So our company was born at Stevens as a senior design project. We have a couple of Stevens alumni working there as well. So can never get too far from Stevens, at least in my case. Awesome. So our mission is to provide landfills with technology solutions that optimize landfill operations, improve gas collection, and as a result of that, drive emissions reductions. So we've got these are kind of the main devices that I'll cover today. One, that automated wellhead, which is we call a smart well. Essentially what it does is it maximizes the percentage of time that a gas well is optimally tuned. No, that's a lot. I will dive into what that means in a little bit. We also have what's called the header monitor, which doesn't do any of the controlling, but allows for continuous and real-time data from anywhere kind of on the landfill. So this device can be placed and we're able to collect data, which just helps to minimize time to detect and correct any issues, leaks, things like that in the field. And then finally, we've got the APIS Cloud dashboard, which is where all of the data that we collect from our devices is then transmitted and you're given a login and can kind of visualize all of those things. Okay, so diving into the smart well, that's a picture of it on the right-hand side of the screen. So we don't actually build any of the wells. They're pre-existing. Our device just sits on top. So kind of what does that mean? We essentially take measurements on the well every 1 to 3 hours. Traditionally, measurements are taken on a handheld device once a month. So you can imagine that there's a bunch more data available here. And then post that measurement, again, traditionally, there's a technician that goes and has to manually tune or kind of just turn the valve on the well. Our device will automatically do that. So we have a control algorithm that adapts to the conditions of each specific well and then acts to kind of maintain the set points of that well. So you're going to tune for specific parameters. So things like methane, flow, stuff like that. Yeah, and then users can remotely, but again, in real time, adjust those valves through their phone, iPad, computer, whatever they're using, request measurements, see, kind of reports, look at historical data, a host of different things that, traditionally wasn't available. And again, what does that allow us to do? It allows us to maximize the percent of time that each well is optimally tuned, which in turn allows us to lower the overall emissions from at least the area of the landfill that has gas collection and control systems. Okay, the right-hand side of the screen, you can see kind of the host of different measurement capabilities we have. So things like gas compositions, pressure, flow, temperature, kind of a lot going on there. Yeah, and then kind of the right-hand side, just kind of some of the core features of the device. I will say all of our devices are solar powered, so you don't need any kind of hard power or battery in order to operate these devices. They do run 24/7, and then all of the data is communicated just through cellular communication, which is also kind of built into the device as it can be kind of spotty. Right. Okay, and then just a quick overview of kind of how the sequence of the device works. So traditionally, when measurements are taken on wells that don't have auto tuning, a technician on the landfill will walk around and do manual readings on all of the different wells across the whole site, which can take days. How ours works is we calibrate our devices so there are more accurate readings. Then the reading is taken. Then that auto tuning piece occurs based on the control algorithm that we have, and then the real-time data is available. So sounds pretty simple, kind of crazy when there's still plenty of landfills in the US that are, manually going around and taking a clipboard and a pen and paper to write all of this stuff down. So it really does allow for more data and kind of better transparency in terms of what's going on at the site and less human error, of course. Awesome. Okay, and then here's our header monitor. You can see a picture of it on the right-hand side of the screen. So essentially it matches all of the measurement capabilities of the smart well. It's just not doing any of that controlling kind of piece, that auto tuning. It can be deployed anywhere on a landfill, underground, 40 feet up in the air, horizontal. We can put it in plants as well for like an RNG or landfill gas to energy situation. Similar to the smart well, they're self-contained, so it's solar panels. Yeah, in terms of this kind of continuous data piece, we can actually hard power it to deliver continuous data every 10 minutes, which is kind of a regulatory aspect for plants and flare stations. They're required to report data every 10 minutes. So that's really the only case where we'd hard power these devices. Every other time during winter, during, pretty severe weather events, we're able to still take those measurements. Yeah, they can last for days without any sunlight. So yeah. And then just some other quick things to note. It integrates with third-party sensors and control systems. So landfills have like fairly extensive kind of SCADA systems and things like that. So we're able to just transmit our data in there, or people are able to go on our dashboard and kind of view everything and download reports. And then I think a really important piece is this particular device is a fraction of the price of a typical analyzer. So not only, so you get more measurements, and it's also like cost-wise pretty comparable. All right, and then without going into too much detail, because I could kind of just talk about this a lot, this is just a snapshot of our dashboard. So yeah, essentially what you have is an at-a-glance review of the entire well field. This is an example, like super zoomed out picture of a landfill, so you can kind of visualize hundreds of acres, and then you can see where our specific automated wellheads are. So this is the geo view. We also have kind of more technical data views where you're able to really see like specific historical analysis in charts, or download Excel reports, things like that. A lot of different options here, but really allows you to track kind of the status of the different wells, as well as if there's ongoing maintenance that needs to be done, things like that. Oops, sorry. Yeah, as you can see, like on the left-hand side of the picture, there's like a device that's red. That means something kind of funky is going on at that well. So from our end, we'll communicate to the site that like, someone needs to kind of go over there and check to see what's happening. So just an example of kind of how the dashboard would get used. All right, in terms of location, where are we based? All over the US, and we have a couple of sites in Canada. We work with basically all different types of landfills, so sites that have RNG capabilities, sites with landfill gas to energy, sites that just have flares, closed landfills. We also work with a mix of private companies, as well as municipalities. So there's a lot of different perspectives and maybe needs that need to be juggled. But so that's kind of a snapshot of what we're doing. I will say too, something that's really cool for us being still a startup. We have an internal engineering team that does all of our own like research, design, and the manufacturing of our devices. So that's pretty cool. And then we do have verification from like third-party firms that have come in and audited and certified that there is gas collection benefits from using our devices. We also have worked with the EPA, and then we tend to work a lot with sites on various like research projects, and sometimes at the state level, like I said, a couple of areas up in Canada as well. Okay, now I kind of want to dive into, the role of data kind of within this space. So, I think it's helpful now that we understand what these devices are and what they do, why is there kind of this massive need for them? Currently, only 60 to 90% of the gas produced in landfills is collected by existing gas collection systems. So that means, along the way, there are, in fact, higher methane emissions. Additionally, there is like requirements for US landfills to be monitored for up to 30 years. So it can get really costly to do, like I was kind of mentioning, those readings and just kind of keeping up with maintenance over those 30 years. Some other things to consider. Landfills are massive. I kind of had no concept of just how big they were until I started working here. But there can be hundreds of wells per landfill. So if you can imagine someone going out there and doing all of those readings, and I don't know if I mentioned this, but the EPA does require, like I said, landfills of a certain size or certain modeled emissions to do monthly readings. So that can be like a massive undertaking, and kind of takes away the time that, people working on these sites could be using to fix infrastructure problems, purely just because they're going out and manually reading. And then for us, there's really the concept of infrequent monitoring is kind of one of the biggest things that our devices tackle. Maybe once a month sounds like good in theory, but you're really just taking a quick snapshot of what's going on at that particular well at one point in time. The conditions in a landfill change, within seconds and minutes. So you could be taking kind of a picture or screenshot of, what's happening at this point in time when your reading is taken. But the actual variation at that well can be pretty massive within a month. Awesome. Okay. I think helpful too to kind of visualize what some common sources of landfill methane emissions are. Anything in red is demonstrating emissions from landfill gas. So obviously, like I mentioned before, there's the active phase where, there's just garbage being filled. So there are methane emitted through that kind of area. So that's a separate issue than kind of what we tackle. A lot of our devices is focused on, you can kind of see in this area where there's the red plumes, poorly operating gas collection systems can create leaks where you get these kind of methane hotspots. So using our devices, you're really able to kind of see how the operations of your gas collection systems are going. And then from there kind of tackle if, there's ongoing maintenance that needs to be done. Awesome. Okay, so how big is the problem? Just in the US, there are millions of tons of carbon dioxide released into the atmosphere per year. And there's been a lot of studies that have come out for the last couple of years showing that the modeling that's done for landfill gas emissions are not really representative of what's actually going on at the site. For example, NOAA last year released a study in conjunction with a satellite-based company showing that landfill gas emissions at, I think it was an average of, I can't remember exactly how many sites there were, but significantly statistic amount of sites, showing that landfill gas emissions were underrated by up to 77%. So we already know it's this massive problem, but now we're kind of throwing into the mix as we have these newer technologies, showing that we're not even really capturing all of the emissions on the sites. So the right-hand side of the screen, this is a company that does satellite imagery mapping, methane emissions. And you can see this site was actually in compliance. And then when you look at this picture here, you can actually see there's massive plumes of methane that were not detected by the site. Again, fully in compliance with, US regulations, but it's just this whole other added piece of the emissions can be actually significantly higher than, traditionally measured. Okay, so I think kind of in explaining how traditional measurements were done, I think first and foremost, there is a need for better data and just more availability of that data, which is something that we can provide. So using traditional measurements, there's roughly one reading a month. Using our devices, if you're just assuming readings every 3 hours for 30 days in a month, you're getting 240 readings in a month. So that equates to a 23,000% increase in data availability. Another note is you're not able to change the data that's being collected. It's all done through our dashboard, so there's no changing any of the numbers or anything like that. So accountability and transparency are kind of a big factor as well in terms of the data that we have available. I think I'm going to walk us through kind of some examples now that I've really dove into kind of what the problem is, how devices work. This is an example of just that rapid problem detection using our header monitors. So this is data obtained from our dashboard. But essentially what you can see is there is a drop in the percent methane content of the landfill gas being collected, as well as the flow. So think first, what does that translate to in terms of a gas collection loss rate? Roughly, that means 45 metric tons of carbon dioxide a day were being released that would have otherwise been collected, which translates to 315 metric tons per week. So, might sound small, but these issues can occur pretty frequently. So they really do add up over time. But using our dashboard, you're able to kind of pinpoint where those issues are happening kind of in real time. So you don't have to wait for the readings to occur or send someone out to go take readings to figure out where the issues are. You're able to just observe kind of this spike, both drop in methane percent, as well as a spike in oxygen and balanced gas. And then kind of what does that mean? It means once the problem is located, the site's able to fix it and they're able to restore gas quality quickly. So not only is it important from an emissions standpoint, obviously when this kind of systems are down, there's higher emissions. But this translates to money for a lot of sites. So this specifically was a site that has RNG. So when they have massive issues like this, translates directly into a dollar loss for them as well. So traditionally, here, I'll explain this really quick. So using the header monitors, you're kind of able to break up the landfill into almost zones, for lack of a better word. So in the past, if a site noticed like this massive issue, they'd have to send someone out again to go and do all of those readings to try and pinpoint an area. Using our site and strategically placing some of our devices on a landfill, you can kind of zone the landfill into different areas. So for example, you can see here we use just 7 of our header monitors to provide data on up to 70 wells. So you can get kind of data on where potential issues may be much faster. And then you're able to just go check like maybe 9 wells instead of, 100. Awesome. Okay, so covered a lot of kind of very technical things. I'm going to shift over to strategy and kind of some of the work that I'm doing. Yeah, I think first and foremost, like really framing why business and sustainability have to align. I think especially with the administration change that we're all kind of witnessing, this is very, very important. From my perspective, some of the pressures that are kind of shaping sustainability, at least in my industry, we're looking at, regulations are tightening. So there's a lot of states actually updating landfill methane regulations. The EPA was in fact supposed to update them, but that's kind of put on pause. Yeah, despite all of that, there's still like a large emphasis on, stricter regulations, specifically around landfill methane emissions. I'd say in our space, there are still a decent amount of financial incentives. Some of the like EPA, IRA grants are kind of put on pause for this space, but for the most part, RNG provides a massive incentive for landfills in this space. There's still a host of tax credits. There's also carbon markets, specifically carbon credits, which sites can apply and generate money for in order to fund other projects. Yeah, I think specifically in RNG, we've seen a 40% increase in operational RNG sites just from 2023 to 2024. So to me, although things might seem kind of grim, there's still a lot of money being kind of shifted into this space. Yeah, that being said, I still think that public expectations are rising in terms of, kind of ESG in general. So we're looking at things like corporate responsibility and transparency are key terms, despite maybe moving away from the conventional labels like ESG. The top left-hand side of the screen, I saw this a couple days ago. Don't call it ESG, call it resiliency. I think we've seen some name changes, but to me, I don't really care what you call it. We know it's important. Businesses know it's important, and consumers are asking for it. Yeah, and I think, another reason that sustainability is and always will be a kind of a business driver is the longer we wait, the higher the cost to, companies, governments, things like that. So the left-hand side of the screen, or the right-hand side of the screen, I have this image here of showing the deployment of different technical solutions to reduce methane emissions. You can see low cost in gray, kind of medium cost in that blue color, and then high cost in the light blue. Obviously, the longer we wait, the more expensive things are going to get. So again, even if we're not necessarily labeling things traditional ESG, there's still money being kind of funneled into this space. And as a result, jobs and things like that. Okay, so kind of going into my job at APIS, really my role is focused on bridging kind of data, business strategy, and then marketing efforts. So kind of what does that mean? So I work a lot on the data work a lot with the data that's already been collected from our devices. And then it's kind of my job to translate that to different stakeholders. So whether that be our customers, partnerships that we have with nonprofits or government agencies, things of that nature. The real challenge of my job, I'd say, is, all of this data exists, but I think especially our job as anyone who's kind of in sustainability, or in my case, a sustainability analyst, it's our job to kind of translate that data into things that make sense to people and make it actionable. So what does that mean? So for example, making landfill methane data usable for different audiences, highly complex. There's a lot of different metrics, a lot of different modeling that's done within this space. So just being able to kind of get all of that work done and then succinctly provide like just one or two stats that show impact can be quite an overwhelming but rewarding job at the same time. I think another part kind of on the marketing effort end is just helping businesses see sustainability, again, even if we're not calling it that, as an advantage. We work a lot with RNG sites who are really focused on operational efficiencies, is kind of the term that they call it, in order to generate more money. Once they, more money for RNG. So, what does that mean? I'm focused again, because they're focused on operational efficiencies. My perspective is going to be, driving emissions reductions. That means the same thing. If operationally we're able to capture more flow, more methane, at these landfills, that obviously translates into emissions reductions, but might just not be the thing that they're most focused on. Yeah, and then I'd say kind of another aspect is just supporting kind of industry shifts and things of that nature in terms of policy with, the data that we've collected and made available. So as I mentioned, there's a lot of both federal and kind of state, I guess question marks might be the right word, around a lot of these regulations. So a lot of my job is just keeping up to date with what those policy changes are going to be, what research is going on. Yeah, that's definitely kind of a big aspect of my job as well. All right. Okay. Say another thing that's really important is this idea of appealing to different stakeholders. So as I kind of alluded to, all using the same data, we're just telling different stories in order to drive real action. So governments are going to have different perspectives, obviously, than, engineers and scientists. So what does that kind of look like? Just these are just some of the stakeholders that I tend to work with. From a government perspective, they're going to be really focused on compliance and regulation impacts versus engineers and scientists who, might be more focused on system performance. Private sector are going to be focused on risk reduction, operational efficiencies, as I mentioned, and profit. And then kind of the public and nonprofits, and at least in my industry, are going to be focused on climate impact and transparency. So kind of what does that translate to in terms of sharing data and kind of telling a story? When I'm working with engineers, I'll be using a lot of Excel spreadsheets, but when I'm working with public NGOs, the government, it's going to be kind of crafting a story of explaining what we do and the impact that we have, versus private sector, which is going to be focused a lot on things like return on investment and kind of calculating the performance and thus translating it into, profit for them. All right. Now I'm going to dive into a case study that I think really ties a lot of these things together. So this is a project that I was working on and will continue to be working on. Essentially, we have a site in Vancouver in British Columbia in Canada. Essentially, they were given a sizable grant from Clean BC, which is just a government initiative that's targeting a 40% reduction in emissions by 2030. So kind of under this grant, they were able to purchase 50 of our devices, along with a host of other activities that supported the RNG project that they have at this landfill. Main objective, though, is to contribute to the overall emissions goal of the grant of 485,000 tons over the next decade. Kind of my role in this is to determine the additional flow and then thus emissions generated to demonstrate that sustainability savings. Yeah, so I will say too, there's a lot of nuances in this space in terms of how things are modeled, but it's normally at the site level. So when we were kind of working through this project, the biggest question I had to kind of answer was, how do we prove our devices have increased methane capture at the well level as opposed to at the landfill level? So kind of what did that look like? A lot of trial and error in terms of kind of data analysis, modeling, things of that nature. Yeah, but essentially the process that we came up with, methodology that was actually later verified by a third party, kind kind of goes like this. So we're going to collect historical data from all of the wells, and then compare it to our device data at a super simple level. But what does that actually look like? The chart on the right-hand side of the screen kind of explains that. So we take the historical measurements and create a trend line from those, taking into account that there's normally only 12 data points a year. So there can be great variation and kind of uncertainty on those historical trend lines. But essentially what we're going to do, we're going to plot that and we're going to generate those trend lines and determine that kind of blue line there is the baseline flow. So without our devices, we're assuming this is how much flow emissions there'd be. Then what we do is we compare to our data and we're able to calculate the contribution from our devices. And then post that, we can calculate the emission savings. I know that was a lot. I've attached a picture of an example of what this looks like. So again, the chart on the right-hand side of the screen. So the solid red line is the historical data. Then you can see the dotted red line also on that side of the screen is the trend line. And then we've extended that out in gray. Then you can see the solid blue line were the measurements that we were taken. The dotted blue line is just the trend line of our data. So you can see that there is in fact a jump or a contribution, so to speak. And then what we do is we're able to calculate anything above that gray dotted line will be positive contribution of, to emissions flow, however we want to translate that, and shows like a positive benefit of using our devices and increasing gas capture. It can also, I will say, sometimes it does dip below, and what that means is either the well's not performing well, our devices aren't performing well, and we move them. So did want to say sometimes it can dip below that trend line. But so this was done for all 50 wells on the site over the course of a year. And then what we were able to calculate were the overall emissions reductions that occurred or emission savings that occurred from our devices. So over the 1-year period, we were able to calculate 17,000 tons of emissions savings using our devices at this site. Yeah, I think this slide does a really good job of kind of speaking to those different stakeholders. We might understand what that means, but maybe the general public or certain government officials don't. So what we looked at a lot was this percent increase. So we know there's a 12% increase in capturing flow from before we were on the site to our first year on the site on those 50 wells. And then translating it even further, if you look at the bottom right-hand side of the screen, you can see that in terms of like the value that provides to RNG, that's roughly $1 million just from using these devices over the course of a year. So pretty massive impact that these devices can have. And again, this is just one site. We're on many. All right. I think I'm doing okay on time here. I kind of just wanted to finish on some closing words on just kind of building your path within the sustainability space. Things that have been told to me that I found were really helpful that I figured I would impart to you all. First and foremost, just really finding your niche. I'd say like sustainability maybe isn't just for scientists. There's definitely a lot of scientists in this space, but I think you can really blend your skills to create fairly massive impact. As I mentioned, my background was in business, and this just became something that I was really passionate about. So it's really cool to kind of be able to bring maybe a different perspective than, an engineer might have, or someone who's, in more traditional science. I do think that's really helpful. I'd say too, like my job is lead sustainability analyst, but I do work a little bit in marketing and kind of the communications of some of the things that we're doing. So whether that be like creating white papers or working externally with other organizations. So can kind of bring that to your job. Two, I really like this bridging the gaps. I can't remember who told me this, but it stuck with me. But essentially, like the best sustainability professionals will bridge gaps between fields. So translate things in a way that makes sense to other people. An example I can think of is right now, I'm working on reducing waste at our company. So obviously I'm focused on the sustainability impact of that, but we have people who do demand planning and kind of forecasting for inventory who are focused on the cost savings from that. To me, again, doesn't really matter what you're focused on. We have the same end goal. So it's kind of pretty cool to kind of create that commonality and work towards a shared goal. My third point here, just making data matter. It's not just necessarily about calculating or knowing the numbers, it's about translating them in a way that's going to be effective and kind of resonate with people. Much easier said than done, but I do think it's definitely an important skill to have, no matter what field you're in. And then number 4 is driving real impact. So really just using your strengths or your passions to shape sustainability decisions and kind of business success. So at least for me, what does that look like? Like if I see that there's kind of a gap in something, that my company is doing, as I mentioned, waste, the first thing I'm going to do is probably put together a proposal to start working on a project. So I do think that, if you bring passion and really rely on your strengths in a job, even if it's something that, you thought you might not be doing originally, you can really drive, again, real impact in that space. Awesome. I've attached my LinkedIn here in case anyone wants to reach out. And that is the conclusion of my talk. Thank you.
Hey, that was excellent. Packed a lot of information in there, and I really appreciated the last slide.